let's talk about relative velocity. Relative velocity is just the velocity of the two particles relative to each other, and the components of, this is a vector, okay? And the components of this vector will just be the difference between the components of the individual velocities. In other words, the relative velocity is just v1 minus v2, okay? So vector 1, velocity vector for particle 1 minus the velocity vector for particle 2, that's your relative velocity. So the x component of the relative velocity would be dx2 dt. That's the velocity of particle 2 along the x-axis, minus dx1 dt. That's the velocity of particle 1 along the x-axis. Okay, so velocity of particle 2 along the x-axis minus the velocity of particle 1 along the x-axis. And you do the same thing for the y component and the z component. And then your relative speed, okay, the speed at which the distance between the two particles is changing would just be, just like any other vector, the magnitude of the vector would just be the sum of the squares of the components, and then you take the square root. Okay, so this is the relative speed. Let's illustrate that with this example right here. Let's say you have a 1 kilogram mass moving to the right. So you have 1 kilogram moving to the right at 1 meter per second. So our velocity is positive 1.0 meters per second. And let's say you have particle number 2 is moving to the left at 1 meter per second also. So velocity 2, okay, so v1x is positive 1, and v2x is negative 1.0 meters per second. Also 1 kilogram, okay? Let's just say they're both 1 kilogram to make things simple. What is our relative velocity? V sub x would be equal to v2x minus v1x, right? And what would that give you? v2x is negative, what is it? Negative 1.0 meters per second, and v1x is positive 1.0 meters per second. So what is that? Oops. It's going to be negative equal to negative 2.0 meters per second. What does that mean? Imagine you're sitting on particle number 1. So here you are. And you're looking at particle number 2. It would appear, because you're moving 1 meter per second to the right, and particle number 2 is moving 1 meter per second to the left. So in 1 second, how far have you separated? You've moved 1 meter to the right, and particle 2 has moved 1 meter to the left. So it appears, from your point of view, you're sitting on particle number 1. It appears that particle number 2 has moved 2 meters to the left. So 2 meters per second. There's a negative there, and that means going to the left. So it appears as though particle number 2 has moved 2 meters per second, because you are setting your origin on particle number 1. So that's what we mean by relative velocity. Okay, and relative speed here will just be 2 meters per second, since we're just talking one dimension here.